Next, we have discussed about environmental conservation and data analysis. See, then environmental conservation and data sector we can find next. CO2 emission reduction. CO2 emission have significant environmental impacts. The accumulations of CO2 in atmosphere contribution to the greenhouse effect, trapping heat and causing global warming. This lead to various adverse effects including rising global temperatures, human health and agriculture, biodiversity and socio-economic system. Therefore, reducing CO2 emission is crucial for mitigating climate changes and minimizing its harmful effect on the environment and human well-being. This involves transitioning to cleaner and renewable energy source, improving energy efficiency, adopting sustainable practice and promotion conservation efforts. Then objects and keys question CO2 emission predictions. Objects are the predictive modeling impact assessment policy supports educational and awareness technological innovations. Key questions: what are the current trends CO2 emission global and regional, and which sectors contribute most CO2 emission and how can they be mitigated? How affect existing emission reduction policies and technologies? What are the potential scenarios of CO2 emission under different economic and policy scenarios? How can advancement in renewable energy and efficiency contribute CO2 emission? These are the quarters. By addressing these key question objective effort be focused on effective strategy to mitigate CO2 emissions that are reducing the impact of climate changes on ecosystems, human health, and socio-economic system worldwide. Then, this imported pandas and speedy imported pandas, matplotlib, seaborns, or other libraries are imported and uploaded this file. These file are CO2 emission file. Here we can see make models, vehicles, engine size, cylinder, transmission, fuel type, fuel consumer, and CO2 emission kilogram. We can see these are the CO2 data set, CO2 file emission data set. We can clearing the data. Next step, uploaded this file, we can see the values, make, models, vehicle class, engine size, cylinder, transmission, fuel consumption, cities, fuel consumptions, highway, combo, fuel consumptions, combo, emission, kilogram. We can see all types of value. Then ECDA variable input. This data set variable are input. ECDA.info, we can see this data set results. Observation, we can see make, object data type, model object data type, vehicle class object data type, engine size, uh, engine size, float data type, cylinder int data type, transmission object data type, fuel type object data, fuel consumption, city, fuel consumption, highway, and float data type. These three are CO2 emission in the fuel consumption in there is the different type of data type. 4 float data type and 3 int data type and 5 object data type. You can observe the dataset values. Then finding null values. Uh, Here we can see null values finding makes models vehicle 0, makes 0, model 0, engine size 0, cylinder 0, transmission 0, fuel type 0, fuel consumption city 0, fuel consumption highway 0, fuel consumption combo 0. Everyone is 0, CO2. There is no missing values. There is no null values, and then unique we can see EDCA dot and unique we can find make 42 model 2053 vehicle class 16 engine size 51 cylinder 8 transmission 27 fuel type 5 211 fuel consumption city fuel consumption highway 143 fuel consumption combo 181 fuel consumption combo 54 CO2 emission 331. Let next we will start data exploring ECDA dot value underscore counts. We can see exploratory data make model vehicle engine size cylinder transmission fuel model make conceptions these values vehicle class these values engine size 5.0 3.5 cylinder 823 293 sorry 6 transmission AS8 and fuel 9.79.0. This is the data set exploratory, and then next we can pie chart convert the data set. First we have calculate sum of CO2 emission for vehicle class. Vehicle underscore class underscore emission ED ECDA grouping by vehicle class CO2 emission G by KM dot sum. Plotting pie chart figure size 10:8 vehicle class emission levels vehicle class emission index autumn straight triangle 140 distribution CO2 emission vehicle class equal pi drawn as a circle. Then we can see pie chart distribution of CO2 emission by vehicle class. Here we can see the values SUV small 50.5 percentage, SB subcompact 8.1 percentage, station wagon small 2.7 percentage, station wagon mid size 2.7 percentage less sorry 0.7 percentage, special post vehicles 1.0 percentage, pickup truck standards 8.8 percentage. Then 2.4 percentage pickup trucks, small pickup trucks and minivan 1 percentage, 4.2 percentage mini compact, mid-size 13.6 percentage, full size 9.1 percentage, compact 12.0 percentage, van passengers 1.4 percentage, van cargo 0.4 percentage, two seaters 6.9 percentage, SUV standard 12.1 percentage, and next we can find the histo chart. Then the values are input intensive EDCA CO2 emission uh, G by km bins 13 kd CO2 emission and frequency Y label. X label CO2 emission. You can see the graph CO2 emission GM distribution of CO2 emission 700 range. Here we can find this histo plot and then bar chart. You can find plot dot figure says 12 8 x is equal to make y is equal to CO2 emission one plot at the EDCA vehicle mark average CO2 emission and rotation for 5. We can find this box plot y axis average CO2 emission G by km vehicle make Aquara Alfa Romeo Astano Maruti Benefit Buck Cadia all types of the vehicles are there Rolls Royce Smart Subway Toyota Volkswagen Genesis this is the graph level and highly Bugattis are there and this graph we can find smart is low level is the grass makes pollution CO2 make this graph vehicles and then next graph we have find scatter chart put the figure size times 6 engine size y is equal to CO2 emission next uh, S label engine size L Y label emission em km we can find the scatter diagram engine size and CO2 emission this is the high 500 range length lower 100 range finally observation certainly type of chart using contact CO2 emission data then pie chart is a circular diagram that illustrates category data proportions through slice of varying size each slice representing a category's contribution relatives to whole data set providing a quick and intuitive visualization of percentage in CO2 emission analysis. A pie chart can sufficiently show which vehicle class of fuel type of contribute most significant total emission, aiding the priority mitigation effort of effectively. This is the pie chart. Next, we histochart CO2 emission. A histogram visualization the distribution of CO2 emission across the dataset. It divides the range of CO2 emission into bin and shows the frequency of emission falling into each bin. This chart helps in understanding the spread and concentration of emission, highlighting and skewness of central tendency in the data. For example, peak or cluster in histogram may indicates common emission level among the vehicle. This is the histogram chart. Next, bar A bar chart displays the average CO2 emission for different vehicle making providing a comparative use of emission level. It helps in identifying which vehicle manufacturer contribute more or less to overall emission. This chart is useful for stakeholders and policymakers to target specific manufacturers for emission reduction strategy based on their contribution. This is the bar chart you can find. Next, we have discussed uh, scatter chart. A scatter plot visualizes the relationship between CO2 emission and engine size for vehicle. Each point represents a vehicle emission level and engine size pair, showing whether larger engines tend to produce higher emotions. This chart helps it identify correlations and pattern between these variable information decisions on engine efficiency and emission reduction strategies. This is the diagram, scatter chart diagram, and finally, this visualization serves a specific purpose in explore and understanding CO2 emission data from distribution and trend to relationship with other variables like vehicle characteristic and fuel type. The facilities informed decisions make for mitigate emissions and promoting environmental sustainability. Adjustments in visualization parameter can enhance clarity and focus on specific aspects of interest within the dataset. These are the environmental conservation and data analysis dataset analyzing this